If we take a look at the box on the top, we are going to start solving trig functions. Consider the graphs of both sides of the conditional trig equation cosine x equals 1/2. The graph shows that cosine of x is equal to 1/2 has two solutions on the interval from 0 to 2 pi. So if we are looking from 0 to 2 pi, the cosine hits 1/2 twice. And that hits it at pi over 3 and at 5 pi over 3. Again, we're just looking from 0 to 2 pi. Since y equals cosine x has a period of 2 pi, which means it's going to repeat every 2 pi, the cosine of x equals 1/2 has infinitely many solutions on the interval from negative infinity to positive infinity. So as we look at one full period from 0 to 2 pi, we're saying that it has two different solutions. But if we look from infinity, from negative infinity to positive infinity, this 1/2 is going to keep occurring. Additional solutions are found by adding integer multiples of the period. So we express all solutions by writing x equals pi over 3 plus 2n pi, and then 5 pi over 3 plus 2n pi. So you're going to find out from 0 to 2 pi what angles we have, and then you're going to add on to n pi, where n is any integer. And that will give us all the 1/2 as we work our way in both directions. So one thing to note, this plus 2n pi, you're going to add that on to your cosine functions, to your sine functions, your secant functions, and your cosecant functions, because all of these graphs have a period of 2 pi. So things will repeat every 2 pi. Another thing to note, though, your tangent and cotangent graphs have a period of just pi. So with these functions, with your tangent and your cotangent functions, you will just be adding on pi times n instead of 2 pi times n. So these four functions, you'll add on the 2n pi, and on these two functions, you'll be adding on just the pi n. Let's take a look at example 1 on how to solve. We want to solve 2 tan x minus the square root of 3 equal to the tangent of x. If we take a look at both sides, we have a tangent on both sides. If we have the same trig function, it makes things a little bit easier, and all we need to do is get that trig function together, just like if it were a variable back in Algebra 1. So I want to take this tangent, the 2 tangent x, and I'm going to move it over to the right because I have this square root of 3 over here on this side, so why not move the tangents over to the right? It doesn't really matter. Just like in Algebra 1 when you're solving for y or x or whatever variable it was, you can really move anything from one side to the next as long as what you do to one side, you do to the other. So let's go ahead and we're going to subtract 2 tangent of x from both sides of the equation. And if I do that, on my left-hand side, a positive 2 tangent x and a negative 2 tangent x is 0, so those will cancel out. And I'm left with, on this left-hand side, just a negative square root of 3. On the right-hand side, I have a 1 tangent x minus a 2 tangent x, which will give me a negative tangent of x. My tangent's not quite by itself yet. I still have this negative number that I need to get rid of. And to do that, I can divide both sides by negative 1. And I end up with positive square root of 3 equal to the tangent of x. And then what I need to do is I need to figure out when is the tangent of x equal to the square root of 3. So what we're doing really is we're taking the inverse of each side. So I'm taking the tan inverse of the square root of 3, and I'm taking the tan inverse of the tangent of x. Oops. So what we want to do is we take the tan inverse of the tangent of x, that x can come out. Now we have x by itself. And I need to find all the possibilities. So a little bit different than when we were just using the inverse function. I want to find all the possibilities from 0 to pi. Since the tangent has a period of pi, and I'm looking for everything, I just need to know in these two quadrants when tangent's going to be the square root of 3. With my tangent function, I do not need these bottom two right now because I'm going to be adding on pi n at the end. And adding a pi to something in the first quadrant will take and bring on that number in the third quadrant. If I add on pi to something in the second quadrant, that takes me right back to the fourth quadrant. So if tangent's positive, that means I'm going to be in the first quadrant. quadrant. So I'm going to go ahead and draw my triangle in the first quadrant. And I need to remember that tangent is y divided by x. So what I have to figure out, you should recognize that if I have a square root of 3 for my tangent, that I'm using my 30, 60, 90 triangle. And what I need to know is what triangle do I actually have? So I need to look at, do I have a triangle in my first quadrant where my 30 degrees in here, or do I have a triangle where my 60 degree angle is in here? And to tell the difference between the two, we have to take on our tangent and actually do that division. So what I'm looking at, if I have the 30 degree here, that means my sine value is 1/2, and the cosine would be square root of 3 over 2. So here I would have 1/2 divided by the square root of 3 over 2, where in this one, if the 60 degree angle was the inside one, I would have the division in the other order. I would have square root of 3 over 2 divided by 1/2. This first one gives me 1/2 times 2 over the square root of 3, giving me 1 over the square root of 3. This other one gives me the square root of 3 over 2 times 2, with those canceling out, and I get the square root of 3. Square root of 3 is what I want out of my tangent. I want to know when that's going to happen. And that's coming from this triangle with a 60 degree angle inside. So if I come back over here, I can draw in my triangle. I know that this has to be 60 degrees. Well, if my inside angle is 60 degrees, then I'm thinking about pi over 3. So I can say that my answer here is pi over 3 plus n times pi. If you have questions, let me know. Otherwise, I'd like you to do the try this, so you can pause it now, unpause it when you're ready to check your answer. If you did the try this correctly, you should get an answer that x is equal to pi over 4 plus 2n pi and 3 pi over 4 plus 2n pi. If you need help, please let me know.